All right, the binomial theorem. This is supposed to help make multiplying out binomials a lot easier. Because the method we learned before to multiply out polynomials, if we had a plus 5 to the fifth, we would have to do, a plus b to the fifth. We'd have to do a plus b times a plus b times a plus b times a plus b times a plus b. Which at this point you guys now know means we have to multiply those two, get that product, then multiply this product by that, and then get that product, and then multiply that product by this, and then get that product, and multiply that by that. That's going to take us some time. Which by all means, yes, you could do it that way. But when you're taking your ACT, you really don't want to. It's a time test. So I forget who the name of whoever it is, but he created this, which let me get us there, which is called, this is Pascal's triangle, but Pascal's triangle can be used for us to multiply binomials. Now it has to be a binomial raised to a power, otherwise we can't do this. Like if we had a plus b times c plus d, you can't use Pascal's triangle to multiply this. So what we do here is this first, we've already discussed all this, so this should be nothing, but this would be like an exponent of 0, this would be to the first power, this would be an exponent of 2, an exponent of 3, 4, 5, 6, 7, etc. Which when you look at the number inside, the number here next to your 1, it should match the exponent there. But anyway, let's go through and do this. So a plus b to the fifth, and we should also already recognize our pattern that the first number here, that exponent decreases while this exponent increases all the way throughout. So I know this is going to equal, I know I'm going to have 1, so here's to the fifth. So I'm going to have 1a to the fifth, and I could write b to the 0, but we know that that means nothing, plus 5 a to the fourth, because this exponent is going to decrease, and now b is going to increase. This was b to the 0, now it's b to the first, or just b, plus 10 a to the third b squared, plus 10 a squared b to the third, plus 5 a b to the fourth, and then plus 1 b to the fifth. I don't like the way that looks. Plus 1 b to the fifth. And there it is. If you wanted to take the time and do a plus b times a plus b times a plus b times a plus b times a plus b, more power to you. But it's going to cause you to miss a lot of questions on your ACT because you spent all that time to do that. And Pascal's triangle is really easy to come up with. Just start at 1, and then you go 1, 1, and then it's just a matter of adding. Your outsides are always 1, and then as you add the 2 terms in front of it, 2. So 1 plus 2 is 3. 2 and 1 is 3, and then 1 carries down. 1 is here, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 carries down. So it's really easy to create. It's nothing you need to have to memorize, because again, you can create it yourself fairly easily. But this a plus b to the sixth, okay, so now we're here in this column, so let's, again, use it here. I'm not going to put the 1s there because we already know coefficients of 1s we don't necessarily need to do. We're going to have a to the sixth plus 6 a to the fifth b plus 15 a to the fourth b squared plus 20 a to the third b to the third. And then I'm going to go plus 15 a squared b to the fourth plus 6 a b to the fifth, and then plus b to the sixth. Because a is now gone, or it's a to the 0, which is 1, and then we have 1 b to the sixth, which is just b to the sixth. Okay, let's look at a plus b to the 8th. I will get you started with this, but I want to check your answers and see what you come up with when you're in class. So basically, I'm going to give you Pascal's triangle to get you started. So you're going to have 1, 8, and you're going to be looking in this row. 29, nope, I can't add. So, sorry. 28, and then 56, 70, 56, 28, 8, and 1. So there's your coefficients, so go ahead and write that out.